2. Let's see if we can finish this up. 8.6. We're doing rational equations still. Before we were kind of adding and subtracting them, and now we're solving them. Okay? So still a lot of the same ideas. And then we're going to look at a weighted average for like story problems. A way to do that. And inequalities. Okay? So, solving. Four sevenths plus 3 over x minus 3 equals 56. So addition. Okay, previously there, we were trying to get a common denominator so we could add things across. Okay, we want to know what that common denominator would be, and then we're going to multiply everything by that common denominator. That's the number we're going to choose to multiply to everything on both sides, and that should cancel out all the denominators and help us solve. Okay, and they help us solve. So, we have 7, we have 56, and we have x minus 3. Well, that's the only x one we have, so we're going to have to use that. 7 is 7, there's not much to do there. And 56 is 7 times 8, or 7 times 2 times 2 times 2. Okay? So the thing is there, I see that 56 kind of overlaps with 7. And I need the x minus 3. So we're going to multiply everything by 56x minus 3, 56x minus 3, 56x minus 3. Okay? We can do that. You can multiply both sides of an equation by the same thing. So I'm multiplying everything on both sides by 56 times x minus 3. Okay, over here, the 56 cancels out the 56 on the bottom. Here, the x minus 3 cancels out. And here, it's a little trickier. 56 divided by 7 is 8. Times 4 is going to be 32. X minus 3 left there. The x minus 3 is canceled out. We have 3 times 56. 168, and then over here we have 53 times x minus 3. Alright, let's do some simplifying. Okay, if I saw this, I might subtract this over and then just have 21 x minus 3's on the other side, but I don't think that you guys would maybe see that. So we'll just expand both of these out. On my notes from last year, I didn't see that either. So I just saw that this time, like, hey, what if we did this? But if you did catch that, you could just slide that over. All right, so we distributed all those. Now we're looking to combine. 32x, put those two together, plus 72, minus 159. All right, so now we got choices. Where do you want to move? What do you want to move where? I'm going to try to keep everything positive, if possible. Not always possible, but if it is, I'd like to do it. So I'm going to subtract the 32x here. So those will be gone from this side. And then I'm going to add, see, this is going to keep my other numbers positive, add the 159 over. Okay. So that's going to give me 231 on the left, 21 x's on the right. Okay, divide by 21, and we get 11 for x. You want to double check that, make sure it works. Okay, or make sure that it Well, the minimum I would do is make sure that it doesn't cause any problems. So 11 minus 3 on the bottom here is going to be 8. That's not going to be a problem. Okay? That'd be the minimum I would do. If you want to go ahead and do these all out on your calculator, make sure it works. 4/7 plus 3/8, and then see if that equals 53/56. What? 4/7 plus 3/8. Math, frac, 53/56. Bingo. Okay. Why don't you try this one on your own? Push pause and see if you can figure that out. Alright, welcome back. So our denominators are pretty easy with this one. So hopefully it wasn't too tricky. A 2x plus 1 and a 3. So there's really no choice. You're going to have to go times 3 times 2x plus 1. 3 2x plus 1. 3 2x plus 1. Okay, nothing to cancel out over here. 2x plus 1 would cancel out there. The 3 is here. Alright, so we have 3 times 10 for 30 in that spot. 4 times 2x plus 1 here. And 6, 2 times 3 is 6. That's as far as we'll take that for now. Okay, just like we were talking about in the last one, we could slide this on over. Instead of expanding both of them, I could just subtract this over right now. This is 4 groups of 2x plus 1. This is 6 groups of 2x plus 1. So if I subtract that over, 30 equals 2x plus 1s. 2x plus 1s. There we go. Drawback of using pen. If I use pencil, it's tough to pick it up on the overhead projector. If I use pen, not good when you make a mistake. Alright, distribute this out. 30 equals 4x plus 2. Subtract the 2. 4x divided by 4, x equals 7. Okay, same thing. The minimum I would do, guys, is make sure that this answer doesn't cause any denominator problems. Alright, it's also not that difficult to just type this in. 10 over 15 plus 4 over 3, does that equal 2? Alright, 2 times 7 was 15. Or 2 times 7 is 14, plus the 1 makes it 15. So we'd have 10 15ths plus 4 thirds. 10 15ths plus 4 thirds, 2. Alright, this next one involves factoring. Okay, so we're going to need to factor this denominator out. Alright, and a lot of these guys, it's going to be super nice, right? X plus 3, x minus 2, gee, I wonder what this one factors out to be. X plus 3 and x minus 2. Okay? And that's going to be what I multiply everything to on both sides. X plus 3, x minus 2. X plus 3, x minus 2. X plus 3, x minus 2. Those all cancel. We just have 122 left on the right. The x minus 2's cancel. We have 10 times x plus 3. And x plus 3's cancel. We have 14 x minus 2's. That was a plus in the middle there. Ooh, tiny writing. Tiny, tiny writing. Didn't leave much room for myself over here. Okay, now we're going to distribute these out. 14x minus 28 plus 10x plus 30 equals 122. Put these together, we got 24x minus 28 and 30 is plus 2. Subtract the 2. Divide by 24. 5. Okay, double check to make sure we don't have any domain errors. That's going to be 8. That's going to be 3. Okay, if it didn't cause any problems in those two, it's not going to cause problems in the factored form of that one. So it should be good. All right. Let's have you push pause and give this one a try. D. Go ahead and give D a try. Okay. Welcome back. Let's see if you were able to get down to 14. Okay. X plus 2, x minus 2. All right, and this one is also x plus 2, x minus 2. So that's going to cancel out. Okay, x minus 2's cancel out. Don't forget now, negative goes with a 3. Negative 3, I bet that's a tricky spot. We lose that negative. So that's going to be negative 3x minus 6, 5x minus 10. Okay. And we're going to break it all the way down there to 14. Simplify, combine, get x by itself, divide, 14. Okay? The inequality ones, guys, think back to last year. This was a fun one. This was a fun, challenging one from last year. Okay? Especially here with we could do this with the other ones of keeping a little note off to the side what x can't be. X can't be negative 2, x can't be positive 2. But it's really important with the inequality ones to make a little note off to the side of what x cannot be. So x cannot be 0 for this one. Okay? 5 times 0 would be 0, cause a domain error. Don't like that. Okay? Now, we're just going to leave this over here for a minute. We'll come back to it. Now it's the same stuff as what we were doing before. What number or what quantity can I multiply to everything to clear out the denominators? Okay, what's the least common multiple of 3, 6, and 5? Okay, 5, 10, 15, but 6 doesn't go into 15. 20, no. 25, no. 30. So 30x is what I want to use for everything. 30x, okay? So the x's cancel here. 30 times 3 is 90. Divide by 5 should be 18. Okay, another maybe easier way to do that was 30 divided by 5 first. 6 times 3, 18. Much easier, right? Make it easier for you. X's cancel. 30 times 1, 30 divided by 6 is plus 5. So this is a pretty nice one. And then over here, 30 divided by 3 is going to give me 10. 10 times 2 is 20x. All right, 23 is greater than 20x. Divide by 20. So we got 23 twentieths is greater than x, or that would also be 1 and 3 twentieths, or 1.15 is greater than x. So the temptation is to just call it this, all right? But the funny part with inequalities in fractions that have x on the bottom, okay, is that it doesn't necessarily always work out that way. It doesn't always work out that way. So this is a special number, 1.15, and then this x can't equal 0 is a special number, and we're going to come back to those, okay? Now we're going to draw just a little number line here, and I'm going to put 0. And I'm going to put my other special number, 1.15. Okay? Those are my two special numbers, what x came down to be and then what x can't be. So now we're going to test some numbers in our original inequality and see if they're true. Okay, what's really nice about this, what's a nice number between 0 and 1.15 is 1. Okay? What's a nice number? So this has to be any number on this side of 0 on the number line and any number on that side of 1.15. Okay? So let's think, if I put negative 1 in there, that's going to be negative 3/5 plus negative 1/6. A negative plus a negative is still going to be a negative. Is that bigger than 2/3? No. And you could type those all into the calculator. You're going to get no. It's not going to be bigger than 2/3. What about 1? 3/5 plus 1/6. Is that bigger than 2/3? So I know that's 0.6 repeating. And this one's 0.6, so it really comes down to what that one is. Let's see, 3/5 plus 1/6, 0.76. Yep, it's bigger than that one. So the inequality would work, yes, for number 1, for 1. If I put 2 in there, see, if I put 2 in there, it's going to make the fractions really small, right? The bottom's big, which makes the fractions small. So if I put 2 in here, this is a 10, 3/10 is only 0.3. Alright, 6 times 2 is 12. Let's say it was a 10 again. That'd be 0.1. That's not going to be close to being bigger than 0.6 repeating, so this is also a no. Okay, so now here's the tricky part. It's between, okay, it's between here. So yes, x was smaller than 1.15 like we had, but it also stops here at 0. So this is the answer, 0, 1.15, we're between it, so we're going to use less thans. There's your final answer. Okay, there's your final answer. That's a tough one. Hopefully this brings back a little bit of memory from last year, doing the same kind of stuff. Alright, I'm going to let you push pause and try this one, and we'll come back together at least for the number line part. But let's have you push pause and try this one. Okay, so 3y, 5y, that's at least 15y times 2 is going to be 30y that we're going to use. That might have been tricky to get 30y. That's going to be our multiplier. Also, we're going to put down over here, y can't be 0. That's going to be our little secret number for the end, or a special number for the end. So the y's would cancel there. 30 divided by 3 is 10, times 4, we got 40. Y's cancel there. 30 divided by 5 is 6, times the 2 makes it 12. Okay, 30 divided by 2 is 15, times 3 is 45y. Okay, so here we are again. It's a little bit different. Okay, last time the x was on the less than side, the small side, and it was a between. This time the y, or the variable, is on the greater than side. Remember our tip from before, greater, or this is probably going to be a split one, but we'll test it out, we'll see. 40 over plus 12 is going to be 52. Okay, not the prettiest of numbers. Divide by 45. It's like 1.15 repeating. Repeating on the 5. Okay, so now I got my special numbers, 1.15 repeating, and 0. 0, 1.15 repeating. Alright, and again it's very close to this, wasn't it? Very close to 1.15 there. So basically the same numbers. And now we can use the same test points. We need a number that's between 0 and 1.15. 1. We can test out negative 1. We can test out 2. Alright. So now we got to see if it makes it true. Smaller than 1.5. So last time the middle was yes. Let's just start in the middle. 1 would make this 4/3 and 2/5 is 4/3 plus 2/5 smaller than 1.5, and we get 1.7. So no, it's not smaller. It's not smaller. Okay? Well, if I put a negative in here, if I put -1 in, that's going to be a negative number and another negative number. Yeah, that's going to be smaller than 1.5. If I put 2 in, or 3 or 4 or 5, let's say you picked 100. Let's say you picked 100, way over here on the right. 100, that's going to make for some really small fractions. 4 over 300 plus 2 over 500, those are going to be teeny tiny decimals. Of course, those are going to be smaller. Okay, so if you get in the outsides, all right, now it's going to be an or. And you're going to have to mirror this, right? It was a less than, not a less than or equal to, so we're still going to be using those symbols. So I need my y to be less than 0 or y to be greater than 1.15 repeating, or if you wanted to use the fraction 52/45, that would also be fine. So these inequality ones can be tricky. All right, we'll see what we got for time here. It's already a 20-minute video. You know what, I'll stop it here, and then we'll make a separate video for the story problems.